Hello everyone, my name is Rahul Rajput. My qualification is BTech UIT Kanpur. So we will be start the magnetic effect of current and magnetism. In magnetism means we have to record the magnetic field. For the observation of magnetic field, let us suppose a wire is this situation and current I's flow is upward direction. Okay, then try to observation of magnetic field. What will be happened? Let us suppose this is the compass, and due to this current the compass will be deflect is this direction, or we can say if I current is flow, then deflection will be right hand side. This is the magnetic compass. Okay, if direction of current is the reverse, is this situation, then magnetic compass will be deflect in reverse. If current I equal to 0, then no deflection of in magnetic compass. And we can say if wire is this and current I is this, if charge is put in these situations, okay, if in wire the current I is flow, then magnetic compass will be deflect in these situations. If direction of current will be reverse, then magnetic compass will deflect in reverse of before situations. Okay, if current I is flow and charge, this charge will be in rest. Rest means velocity of that particle equal to 0. Okay, if current I is flow and any charge will be put near the wire, then velocity of charge which will be equals to 0, then there is no acted the force. Okay, and if current I is flow and charge q and velocity of charge cannot be equal to 0, means velocity of charge, let us suppose velocity of charge which will be equals to 2 meter per second, then that charge will be deflect. That charge will be deflect. Let us suppose that charge will be deflect in these situations. This charge cannot be go vertically upward. This charge will be deflect towards the wire. Okay, so we can say for a moving charge there exists a magnetic effect. For a moving charge there exists a magnetic effect, or we can say if electrical field is this, let us suppose electrical field is this, let us suppose this is a charge q and electric field is this, then force on that charge which will be equals to q into E, if charge q is the positive. Okay, if charge q is the negative, then if charge q is the negative charge, then direction of force will be the opposite to the electrical field in these situations, then Fe equals to q into E, right? So we can say nearby wire the magnetic field will be created, nearby wire the magnetic field will be created, and if velocity of charge which will be equal to 0, then that charge cannot be deflect, because nearby wire will be the magnetic field. So magnetic field cannot be deflect to the charge, because for deflection of charge we need the electrical field. Also we need the magnetic field. Magnetic field, if charge q is velocity v, then magnetic force will be effect. Fm equal to qv cross b. After some time I will be discussion about the magnetic force. Fm vector equal to qv cross v, means Fm vector equal to qv vector cross b vector. Okay, means if any charge is kept and velocity of charge will be given in that magnetic field, then magnetic force will be effect. In these situations magnetic force will be effect. Okay, so implies that we can say magnetic field will be created for these situations. Okay, here magnetic field will be created, here magnetic field will be created, here magnetic field will be created, here magnetic field will be created. Okay, here magnetic force will be created, magnetic force will be applied. Here cannot be magnetic force will be applied, because for magnetic force Fm equal to qv cross b, we have to need the magnetic field and v. Okay, we have to need the magnetic field and velocity vector v. So let us move on the next point. Biot-Savart law. Biot-Savart law. It is the silent. So Biot-Savart law. What is the Biot-Savart law? If wire is given I, and if we calculate the magnetic field B due to this wire, okay, so according to Biot-Savart law, let us suppose this is the dl is the small element. Due to small element, we have to need the magnetic field at point P, which is this situations. We have need the magnetic field at point B. Okay, this is the element vector. This is the current will be vertically, current will be upward, and we have to need the magnetic field at point B. This is the R vector. Okay, this is the R vector. Implies that according to Biot-Savart law, we can say dB vector equals to mu naught by 4 pi I dl vector cross R vector divided by R cube. Important point is this: the direction of dl, which is the direction of current. The direction of dl, which is along the direction of current. If direction of current will be upward, then dl vector will be upward. Dl vector is the length element, small length element, elementary length. And if direction of current will be downward, then dl vector will be downward. And the R is the position vector with respect to the dl vector, which is from dl vector elementary length vector to the where we have to need the magnetic field B. Implies that this is the R vector, this is the dl vector, and angle between dl and R, which is the, let us suppose this is the theta. Okay, so due to this dl vector, we have calculated the magnetic field dB. This is the small length, so this is the small magnetic field B. Implies that dB equal to mu naught by 4 pi I dl vector cross R vector divided by R cube. Okay, so this is experiment by the Biot-Savart law. dB vector equal to mu naught by 4 pi I dl vector cross R vector divided by R cube. So this is the Biot-Savart law in vector form. Okay, let us suppose a wire is given, the current in wire which will be equals to I, and we have to need the magnetic field P, which is due to dl vector, due to small length vector dl vector, magnetic field is the dB, and the distance between the dl and P, which is the R vector. So direction of position vector of R, which is from the dl vector to the P, which is the right hand side, which is the from dl to P. Okay, so according to Biot-Savart law, dB vector equal to mu naught by 4 pi I dl vector cross R vector divided by R cube. This is in vector form. Okay, so if we need the in scalar form, then what will be happened? dB vector mod equal to mu naught by 4 pi I. We have to need the taking modulus both side. Mu naught by 4 pi and I is the positive, so we can take outside the modulus value. Implies that this, and R cube also is the positive number. Here this is the dl cross R. We know that if two vectors are given, let us suppose A vector cross B vector, which will be equal to mod A mod B into sine theta into n cap. This is the A cross B. We have to need the mod of A cross B. So taking mod both side, A cross B, which will be equal to mod of A. So this is the distribution mod of B. This is the mod of sine theta. Here this is the n cap mod. Okay, mod of A. Mod of A is the positive number. So we can take out the modulus of A only. Modulus of A. Similarly, mod of B is the positive number, because according to modulus property, mod of x, which is the, if x is negative, then mod x equal to minus x. If x is positive, then mod x equal to plus x. Implies that mod A into mod B into sine theta. We know that the angle between A and B, let us suppose this is the A vector and this is the B vector and this is the angle theta. So angle between A and B, which is lie from 0 to 180 degree, with including point 0 and 180 degree will be including point. Imply that we can say for sine theta, because this is the mod of a sine theta. This is the mod of a sine theta, which will be equal to mod of a sine theta. What will be happen? The graph of mod of a sine theta, the graph of sine theta is this. If angle is 90 degree, this is the 0, this is the 90, this is the 180 degree. If angle between 0 to 180 degree, then sine theta will be positive because in A cross B, the angle between A and B must be 0 to 180 degree. 0 to 180 degree. So mod of a sine theta is the positive. So also this number is the positive. So remove the mod number. And another point is the into n cap. N cap is the unit vector. Mod of a unit vector which will be equals to 1. We know that mod of a unit vector which will be equals to 1. Mod of a cap. If A is the vector, A cap is the unit vector, then A cap equals to A vector divided by mod of A. If we take the mod both side, then A cap mod equal to mod of A vector divided by mod of A. So mod of A, only one mod, equal to mod A divided by mod A equal to 1. So A cap mod which will be equals to 1. That number equals to 1. Implies that mod of any unit vector which will be equals to 1. So we can say this number equals to 1. Implies that A cross B modulus equal to mod A mod B into sine of a theta. Okay. Here is this mu naught by 4 pi I by r cube. Vector A equal to dl vector, vector B equal to r vector, implies that. Putting in this value, so dl, only dl, because mod of A we can write equal to only A, and into r and into sine of theta, where theta is the angle between dl vector and r vector. This is the dl vector, this is the r vector, so this is the theta vector. Okay, and always take the angle between A and B which will be 0 to 180 degree. So 0 to 180 degree, not this angle, this angle will be 0 to 180 degree. Means if angle will be take in this situations, let us suppose this is the A vector, this is the B vector, this is the tail. So angle between tail and tail, so this is the A vector and this is the B vector. So angle between head and head, this is the angle theta, this is the correct. If this is the A vector and this is the B vector, if this is the angle theta, so this is cannot be angle theta. Okay, this is cannot be angle of theta, because this is the head, this is the tail. So trying to angle between tail to tail and head to head, then that is the correct information. This is the not a correct information. Okay. Also you can say this is the mu naught by 4 pi I by r cube dl. So this is the cancel, remove the r and r square, mu naught by 4 pi I by r square I dl sine theta, this is the dB. So dB equal to mu naught by 4 pi I dl sin theta divided by r square. So this is the magnetic field according to the Biot-Savart law in magnitude form. This is the in vector form. Okay, let us move on. So right here dB in vector form, which can be written as dB equal to mu naught by 4 pi. This is the mu naught by 4 pi I into dl vector cross r vector divided by r cube. dl vector cross r vector divided by r cube. dl vector cross r vector divided by r cube. Also we can write here in these situations mu naught by 4 pi I into dl cross r vector we can write here r vector divided by r, which is the r unit vector. So r cube will be written as the r and r square. There is the no effect because this is the scalar number, is the scalar number, this is the vector, this is the vector. Okay, so r vector divided by r, which is the r cap, implies that dl vector divided by r square, and this is the r cap, implies that we can say, we can write here in these situations dB vector equal to mu naught by 4 pi I dl vector cross r cap divided by r square, r cap divided by r square. Okay, this is the r cap, this is the r vector divided by r cube, this is the r vector divided by r cube, implies that we can write in magnitude form, then dB vector in magnitude form, which will be equal to mu naught by 4 pi I dl sin theta divided by r square. So this is the scalar form, this is the vector form in two situations. Okay, first in vector form, second in the cap, in terms of a cap. Okay, and another point is the direction of magnetic field B. The direction of magnetic field B, what will be happened? The direction of magnetic field, so the direction of magnetic field, first by screw rule, okay, by screw rule means the direction of a magnetic field B will be along the direction of dl vector cross r vector, along the dl vector cross r vector, implies that this is the dl, this is the r, so implies the direction of dl cross r, which will be is the same the direction of dB. Okay, which will be same the direction of B. This is the by screw rule. What is the screw rule? If we take is the magnetic field in these situations, let us suppose this is the magnetic current I, we need the magnetic field B at P point, direction of magnetic field at P point. Let us suppose the dl vector is always along the current I. This is the dl vector, current I. We have to need the magnetic field dB at P point, or this is the angle theta, implies that screw rule, what happened? This is the put the thumb at intersection point at tail of dl and r vector. This is the r vector, implies that we move from dl to r, because dl cross r, dl to r, this is the dl, this is the r, so move from dl to r. So thumb will be goes inside the board, thumb will be goes inside the ball, implies that we can say the direction of a dB at P point will be inside. The direction of inside will be always cross, direction of upper outside will be dot. This is the direction of inside will be cross, direction of outside will be the dot. Okay, to the plane in which plane we are observing that point. In these situations the wire is put in this whiteboard, so direct cross is represent the inside the whiteboard. Okay, inside the whiteboard, this is the inside the whiteboard, and outside the whiteboard, if we comes from outside the whiteboard, then that will be the outside the whiteboard. Okay, if we change the direction of current, if the direction of current is this situations, if we need the magnetic field at P point, okay, so this will be take the dl vector, will be take the dl vector will be the downward, because current will be the downward. Okay, and r will be the, in this situation, this is the r, imply that we can say according to the screw rule we are applying the dl cross r vector, put here dl cross r vector is this situations. So this is the dl cross r vector. Okay, this is the angle theta. We can take always, this cannot be sensed, we can say this cannot be sensed dl cross r vector, because we can take smallest displacement dl to r, this cannot be take, this is the dl, this is the r, so this is the longest displacement, we take the small displacement is this dl cross r. Okay, so dl cross r is this, implies that we can say direction of a magnetic field which will be the this is the inside, this is the outside, because this is the dl cross r, so thumb will be goes to the outside. Okay, and if we cannot understand by the screw rule, so another point will be the by right hand palm rule. Right hand palm rule, right hand what will be here is a, if dl is this, if current is this, and this is the dl vector, if we need the magnetic field at point P, so this is the r vector is the from dl to P point. Okay, so this is the angle theta. So implies that we are trying the right hand rule, implies that this toe will be, this thumb will be goes to the direction of dl will be along the current. Okay, dl will be along the current, so this is the dl, or we can say this is the current, so current will be is this situations according along the thumb, and if we need at P point, then that finger will be curl, implies that we need the magnetic field at P point, so according to this situation this is the curling point. Okay, so this is the magnetic field at P point which is the inside. If we need the outside, for this situations, if we need the magnetic field at point Q, okay, this is the dl vector and this is the r vector. Okay, we need the angle theta, this is the theta prime. Okay, so implies that here we need the magnetic field at P point, at Q point, and this is the dl, so this is the curling point, implies the magnetic field at Q point which is the outside. Okay, this is the outside, this is the inside, so this is the right hand palm rule. This method is the easy method. Okay, right hand palm rule, but this method is 100% apply for any situations, because if dl and r vector is given, dl vector let us suppose 4i cap 3j cap plus 5k cap, and r vector equal to 10i cap plus 2j cap, then we have to use the formula dB equal to this formula. Okay, a cross b, then that magnetic field up in terms of a I, J, K, and we cannot use the right hand rule. Right hand rule cannot be used. we use the by screw rule. By screw rule, A cross B, this is the 100% true. Okay. Now let us move on the next point. Find the direction of magnetic field at these situations. Magnetic field at these situations. Let us suppose this is the wire current I. We need the magnetic field at this point. Let us suppose P point. And next point is the magnetic current I and magnetic field at P point. Okay. Another, if current is going inside current, then magnetic field at point P. If current is going outside, the magnetic field at point P. Okay. So we use the right hand rule, right hand palm rule, which will be equals to what will be how you can use the current I along the thumb and curling at which point where we have to need the direction of magnetic field dB. This is the current I, or this is the point P. Okay, so this is the current I, this is the point P. Then you can curl at this point, at P point, I current and P point. So this is the direction of magnetic field inside, because curl will be the inside. This is the current I, curl, and at these situations current I is this given. So direction of magnetic field, what will be happened? This is the I current, and at this situation we have to need the magnetic field. This is the outward directions. So magnetic field at point P due to this wire will be outside, and this wire will be goes the perpendicular to the plane, and current will be goes the inside. So inside will be the thumb will be direction will be inside, and magnetic field at P point. So this is the this situations. Okay, so this is the R vector, and also this is the important point. This is the magnetic field dB. So angle between this situation will be 90 degree, because we know that dB equal to at these situations. So dB is perpendicular to the dl vector, and dB is perpendicular to the r vector. Okay, dB is perpendicular dl and dB is perpendicular to r. So dB is this is the r, so this is the angle 90. Okay, and at point P the current will be the outside, then at point P the direction of magnetic field will be in these situations. So this is the r vector, and this is the dB. So this is the dB. Okay, angle between that situation equal to 90 degree. Okay, so this is the direction of magnetic field at 4 situations: first, second, third and fourth. Note down. And according to the book, you can say the magnetic field dB. The magnetic field dB is the directly proportional to the I, and magnetic field dB is the directly proportional to the dl, and magnetic field dB is the proportional to the 1 upon r square, or we can say is the inversely proportional to the r square, or we can say dB is the inversely proportional to the square of r, or the distance between the dl and P point. Okay, and also dB is the directly proportional to the sine theta. What will be dl? Look here, this is the current I, this is the point P. We have to need the magnetic field dB. Let us suppose this is the dl vector at point P. this is the angle theta, this is the dl vector. Along these situations, this is the position vector r. Okay, so we can say dB is directly proportional to r. If I is increased, then dB is also increased. If dl is increased, elementary length dl is increased, then dB is also increased. If r is the increase, if r is increased, then dB will be the decrease. Okay, if theta is the increase, then dB is the increase. But that the limiting case. Limiting case means the angle between 0 to 180 degree. If theta will be increased up to limiting case, means theta will be increased. This is the important point. If theta will be from 0 to 90 degree, okay, so dB will be increased. dB will be increased. Theta is increased, then dB will be increased. If theta will be increased from 90 to 180 degree, 90 to 180 degree, then we can say we can say dB will be decreased. dB will be the decrease. dB will be the decrease. Is this situations? dB will be the decrease. Okay, because the sin theta is this. This is the 90 degree. This is the 180 degree. Okay, if theta is the increase, then sin theta is also increased from 0 to 180 degree. If theta is the increase from 90 to 180 degree, then dB will be the decrease. Okay, so this is the Biot-Savart law according to the bookish language. Okay, you can write in copy according to the board level. dB is directly proportional to the I, dB is directly proportional to the dl, dB is the inversely proportional to the r square, and dB is directly proportional to the sin theta. Theta is the lie between 0 to 90 degree, then dB is the increase. If theta is the 90 to 180 degree, then dB will be the decrease according to the figure. Okay, so move on the next point, that is the magnetic field due to state current carrying wire. Magnetic field due to the state current carrying wire. Magnetic field due to state current carrying wire. We have two magnetic field due to state current carrying wire. Okay, so what is the state current carrying wire? Let us is this situations. This is the current I, this is the state current carrying wire, state wire, A point and B point. Okay, we have to need the magnetic field at these situations. We have to need the magnetic field at these situations. Let us suppose at this point, this is the P point. Okay, so we are drawing the perpendicular from P point on the wire AB. Where AB, this angle is the 90 degree. Okay, this angle is the 90 degree, and the angle from P point to the to this part will be, let us suppose, phi 1, and this situation is the phi 2. Okay, this is the phi 1 and this is the phi 2. Okay, this is opposite sense, phi 1 and phi 2 from this line. If this point is the M point, MP, okay, MP line, this is the angle phi 1, this is the angle phi 2, and we have to need the magnetic field due to AB wire at P point. The current in the wire is I, and angle is the phi 1 and phi 2. This angle, if this is the clockwise, this is the anti-clockwise. Okay, so using the Biot-Savart law, we are using the Biot-Savart law, then what will be happen? Look here, using Biot-Savart law, then let us suppose this is the L length, we cut the DL length, this is the DL length, this is the DL length, this is the DL length. okay, from L length to DL length, okay. Imply that we can say this point is the theta, this point is the theta, okay. Let us suppose this is the theta. If you are not confusing, then you can take this is the theta 1 and this is the theta 2. There is no problem. Theta 1 and theta 2. Okay. So this is the theta, this is the theta 1, this is the theta 2. So at theta equal to theta, this is the distance r, because the current will be upward direction. This is the dl is the small length, and this is the I current, and this is the distance r. Okay, we have to need the magnetic field at P point due to this small part dl, elementary length dl. Okay, so using the Biot-Savart law, using the Biot-Savart law, dB equal to mu naught by 4 pi I dl sin theta divided by r square. Dl is this, okay, r is this, and theta is the angle between dl and r, and that theta will be the smallest displacement theta, smallest angular displacement. This is the dl, and this is the r, and this is the smallest displacement. Also this is the displacement, but this is the larger displacement, but we have to need the smallest displacement theta. Okay, then how you can calculate the angle theta? This is the theta angle, this is the 90 degree, and this is the angle 90 minus theta. Okay, we have to need the dl and r. This is the dl vertically upward, and r is this from dl to P point. So this angle is equals to, total line is the 180 degree, so 180 minus 90 minus theta. What will be happen? This is the 90 and plus theta, implies that the angle between dl and r, which will be equals to 90 plus theta. So put here 90 sine of 90 plus theta, okay, is this angle. Theta cannot be put because theta is not a correct situation. Theta is this angle, okay. So in this triangle, this angle is the 90 degree, because this is the this line in the perpendicular. So this is the 90 minus theta. So whole line totally is this given. Total angle is the 180 minus 90 minus theta, which will be equals to 90 plus theta. So sin of 90 plus theta, we know that sin of 90 plus theta equals to cos theta, because 90 plus theta which goes into the second quadrant, in second quadrant sin will be converted into cos, okay, but positive. Sin will be converted into cos but positive. So this is the cos theta, okay. Mu naught by 4 pi I dl cos theta, I dl cos theta divided by r square, So this is the dB. In these situations, this is the important, very important point. Okay, I dl and cos theta and r, we are trying to solve out in function of theta. Totally variable. Look here, the number of variable. How many number of variable? This is the theta variable and r variable and dl variable. Theta variable, if theta will be changed, then r will be changed, and dl is also variable. This is the small length. Dl can be increased. Okay, so total variable will be converted into the theta. We are trying to the this dB only one variable. This is the theta. Okay, so in this triangle, in right angle triangle, what will be right angle triangle? Is this right angle triangle. So this is the r, and this distance will be the a. This is the also given point. Sorry for that point. The wire and P, which is the perpendicular distance, is the a. So this is the a is given, and this is the r. This is the angle theta. Okay, we are trying to solve out. Cos theta equals to, okay, cos theta. Then cos theta equals to, what will be happen? Cos theta. In this triangle, cos theta equal to base upon hypotenuse. This is the base, this is the hypotenuse, this is the angle theta. In front of angle theta, this is the perpendicular, this is the base. So cos theta equals to, what will be happen? Cos theta equal to A divided by R based upon hypotenuse. Okay, and also we are required the tan theta. Look here, cos theta equals to A by R. Okay, what will be happen in terms of a cos theta, which is the A by R. Okay, cos theta equals to A by R, or we can say R equals to A by cos of theta. That R will be converted into f of theta. That R will be converted into f of a theta. Okay, that R will be converted into f of a theta, because A is the constant and theta is the variable. Also we can reduce the dl. How you can reduce the dl? This is the L, because this is the L length. At L equal to dl, we are observing that. So we can say tan theta. Tan theta equals to perpendicular upon base, perpendicular to the L, and base is the A. Base is the A. Okay, so we can say here L equals to A into tan theta. A into tan theta. dl is the differential length, small length, imply that we can say we are differentiating this the dl with respect to theta. So d by d theta of L equal to, A is the constant, d by d theta of tan theta. Then what will be happen? D by d theta of tan theta equal to A into sec square theta into d theta divided by d theta, or we can say d theta divided by d theta is the cancel out. So dl divided by d theta, so transfer the d theta in the right hand side. So dl equal to A into sec square theta into d theta. dl equal to A sec square theta into d theta. Okay, so we put in place of a dl and in place of a r, whole function will be converted into theta. Implies that db equal to mu naught by 4 pi I into dl. In place of a dl is the A into sec square theta into d theta, also into cos of a theta. Cos theta, we can write here cos theta, no problem, divided by, this is the r square. R square is the r, we can say A into sec theta, because cos theta will be moved in the numerator, so we can say A into sec theta. R square is the A square into sec square theta. Okay, so this is number will be cancel out, this is the A will be cancel out, implies that mu naught by 4 pi I by A into cos theta into d theta. Okay, this is the dB. Magnetic field dB is this situations. Okay, so this is the, due to small element dl, which will be magnetic field dB equal to mu naught by 4 pi I by A into cos theta into d of theta. We are trying to find out the net magnetic field. We are trying to find out the net magnetic field, so we can integrate both sides. mu naught by 4 pi constant, I by A constant, theta variable, so implies that differentiate integrate at these situations. This is the phi 2, so this will be take minus phi 2, this is the plus phi 1, this is the clockwise, this is the anti-clockwise. Okay, clockwise and anti-clockwise, so minus phi 2 to phi 1. Okay, you can take this is the minus phi 1 and this is the plus phi 2, no problem. Okay, finally we can take magnetic field mod, so finally answer will be same. Imply that integration of cos theta into d theta, what will be happen? Sin theta into d theta. So dB equals to mu naught by 4 pi I by A into sin theta, which will be the lower limit is the minus phi 2 and upper limit is the phi 1. Okay, mu naught by 4 pi into I by A into, this is the, in place of a theta we can put in place of a theta we can put phi 1. You can say phi 1 or phi 2, no problem. Here we can put the theta 1, here you can put the theta 2, this is the no problem. Here you can put the theta 1, here you can put the theta 2. So sin of a theta 1, sine theta 1 in place of what theta, and minus of minus lower limit. Here this is the minus sine theta 2. Sine of a minus theta equal to plus minus sine theta, minus minus plus. This is the magnetic field dB. So dB equal to mu naught by 4 pi I by a into sine theta 1 plus sine of theta 2. Okay, so this is the magnetic field due to straight current carrying wire. This is the angle theta 1 theta 2, but theta 1 theta 2 must be a opposite sense. This is the clockwise, this is the anti-clockwise, or we can say this is the anti-clockwise, this is the clockwise. Both will be in opposite sense. If we can take is the clockwise, then theta 2 is the anti-clockwise. Okay, and a will be the perpendicular distance. A will be the perpendicular distance. Okay, this is the 2 point will be important. First point is the angle is the clockwise and this is the anti-clockwise, and this is the a is the perpendicular. So mu naught by 4 pi I by a into sine theta 1 plus sine theta 2. This is the magnetic field due to whole wire. Okay, this is the a distance, this is the theta 1 theta 2, and this is the current I. Okay, note down. And let us take one example on these situations. Magnetic field due to straight current carrying wire. Let us suppose this is the current I. This is the current I. We have to need the magnetic field at this point. This is the 2 meter. This angle is the 30 degree, and this angle is the, let us suppose, 60 degree. Opposite sense. Theta 1 is the clockwise, theta 1 is this, and theta 2 is the anti-clockwise. So magnetic field at point P. So dP equal to mu naught by 4 pi I current, I let us suppose the 4 ampere. This is the 4 ampere. 4 divided by r square. I by a. A is the perpendicular distance. This is the 2 meter is the given. 2 meter into sine theta 1. This is the sine 30 and plus sine theta 2. This is the sine 60. This is the sine 60. Implies that mu naught by 4 pi. This is the 2. Mu naught by 4 pi equal to 10 to the power minus 7. This value will be the 10 to the power minus 7 mu naught by 4 pi. And this is the 2, and this is the sine 30. Sine 30 equal to 1 by 2 and sine 60 equal to root 3 by 2. Arranging this number, so we can say 2 into 10 raised to minus 7 into root 3 plus 1 and divide by 2. This 2 will be cancelled out. Implies that root 3 plus 1 into 10 raised to minus 7. That is the Weber per meter square. This is the magnetic field B at P point. Okay, note down. And let us take the another questions. Let us square. Let us take the another questions. Due to square, we have to find the magnetic field at the center of the squares. Let us suppose this is the square. Let us suppose the current I is flowing in these situations. Current I is flowing in these situations. We have to find the magnetic field at the point of intersection of diagonal of a square. Which side is the A? Square of side is the A, and current I is flowing in the anti-clockwise directions. The direction of magnetic field will be the outward direction, because by right hand palm rule, this is the thumb will be goes to the current. Let us suppose this is the A, B, C and D. Due to AB, the direction of at this point, this is the intersection of the diagonals. Intersection of the diagonals. Let us suppose this is the intersections. Intersection point will be the O. and we know that this is the current I, and we have to find the magnetic field at point O. This is the current I will be along the thumb, okay, and we have to need magnetic field at O point due to AB, which will be vertically upward, and same due to BC, current I, and this is the magnetic field upward, current I upward, implies that due to magnetic field due to AB, direction will be upward, magnetic field due to BC, direction will be upward at A point, magnetic field due to DC, direction will be upward, magnetic field due to DA, magnetic field will be the upward, implies that net magnetic field which will be equal to 4 times of a magnetic field B1. Let us suppose due to this wire magnetic field is the B1, and we are trying to find out the magnetic field due to B1, due to B2, due to B3, that is the same or not same. If same, then you can write 4 times of a B1. How you can write? If B1 equals to B2 equal to B3 equal to B4, if magnetic field will be same, then you can write net magnetic field at point O, which will be equals to 4 times of a B1. So at O point, what will be the magnetic field? Check out. This is the wire AB. This is the wire AB. This is the O point. We are trying to perpendicular distance. Okay. This is the A point. This triangle is the isosceles triangle, because this is the diagonal. This is the diagonal. OA and OB equal to OA and OB will be same due to property of square. So perpendicular distance from O point to AB, which is the bisected. If A distance is this, then that is the L by 2. This is the A by 2. Let us suppose this is the A by 2, and also this is the A by 2. Okay. This angle will be the 45. This angle we know that is the 45. Okay, because this is the bisector aapka, this is the whole 90, this is the 45. Also this angle is the 45 degree. Okay, so this angle is the 45 degree. If we take this is the 45 degree, this is the 45 degree, opposite sense, theta 1 equal to 45 degree and theta 2 equal to 45 degree. We have to need the magnetic field at O point. Okay, then R equal to, or we can say this is the perpendicular distance. So B1 equal to mu naught by 4 pi I by perpendicular distance. This is the angle 45. Okay, so this is the L by 2. Then what will be happened is this this length. Let us suppose this is the OM. So this is the 45. This is the perpendicular. So sine 45 equal to what will be happened, or we can say tan 45 equal to perpendicular upon base, perpendicular P divided by base is the A by 2. Okay, this is the A by 2, implies that you can say P equal to A by 2, tan 45 is equals to 1. Okay, so this is the A by 2, also this is the A by 2 length. Okay, so this number is the A by 2. Next point, theta 1 is the 45 and theta 2 is the 45, that are the opposite sense. Sine 45 plus sine 45, sine 45 plus sine 45, sine 45 is the 1, sine 45 is the 1 plus 1 equal to 2, and by that we can say that value equal to mu naught by 4 pi, here I divided by A is the A by 2, this is the 2, this is the A by 2, so 2 goes this is the upward direction, so that number is the into is the 4 divided by A. Okay, so this is the magnetic field due to AB wire, magnetic field due to AB wire at O point, but we have to net magnetic field at O point. So B1 equal to B2 equal to B3 equal to B4. You look the this figure. Also this is the 45, and this is the A by 2. Also this is the A by 2. Similarly, at all situations B1 equal to B2 equal to B3 equal to B4. Imply that we can say B net equal to 4 times of a B1. So B net equal to 4 times of a B1, 4 into B1. B1 is the mu naught by 4 pi, 4 I by A into 4. So this is the net magnetic field due to this square. In this square, current I is given and A is given. Okay, so mu naught by 4 pi, 4 times of I by A into 4. Okay, thank you.